the question says that when GC4H10O is heated in a sealed container. So a sealed container, that means a reversible reaction can happen, right? So reversible reaction and an equilibrium mixture is produced. So at equilibrium, you find this as a product, carbon monoxide and methane gas, and also you get the reactant on the equilibrium as all of the reactant does not convert into product, right? So complete the expression for the equilibrium constant Kc for this reaction, state the units of Kc. Now, in order to write the Kc unit, we know that we write the concentrations of the species on the right hand side in Kc expression, right? And the concentrations of the species on the left hand side, and we mention them over here. We do not mention substances which are solid in nature in Kc expression. So in this equation, there's no solid, so we're easy to go. So right hand side, that's C2H6 to the power what? It's 1 mole, so 1 into, we have carbon monoxide to the power, sorry, we have carbon monoxide to the power 1, and you have CH4 gas to the power 1 also. All this divided by the left hand side in which you have only one reactant, which is C4H10O to the power 1. This would be the Kc expression, and in order to write the units, you need to write the units of all the brackets. So you have mole per dm cube into mole per dm cube into mole per dm cube in the numerator, and only one time you have mole per dm cube in the denominator. So this cancels out with this. You're only left with 2 mole per dm cubes in the numerator. That makes mole per dm cube square. So now if I replace the unit, that would be mole per dm cube, and I have to apply a square on that. Right? So this square applies on mole, mole becomes mole square, and dm minus 3 becomes my 3 times 2 is minus 6. So the unit is mole minus 2 dm 6, positive 6. Sorry, mole 2 and dm minus 6. I've written the opposite. So mole 2 dm minus 6 is the unit for Kc in this expression. Right? So question number 2 says a sample of Hi is added to 2 dm cube sealed vessel. So it's a sealed vessel. We know that a reversible reaction is going to occur, and the vessel is of 2 dm cube volume. All right. So the volume is 2 dm cube at 764 kelvins and allowed to reach equilibrium. Reaction 1 is given. The Kc value for the reaction is also given. It says at equilibrium, the mixture contains these many moles of Hi. State one difference in the appearance of the initial reaction mixture compared to the mixture at equilibrium. So the initial reaction mixture is Hi gas, right? It's a colorless gas. It does not have any color. But when the reaction starts to proceed, you produce what? You produce iodine, right? Now, iodine in gaseous form is what? What's the color of iodine in gaseous form? It's purple vapors. So you're going from colorless mixture to a darker mixture or a purple mixture, right? So state one difference in the appearance of the initial reaction mixture compared to the mixture at equilibrium. So we'll say the mixture at equilibrium is purplish, or we can say that it is darker in color. All right. So deduce the expression for the equilibrium constant Kc for reaction 1. We have reaction 1. Reaction 1 is Hi gas goes into H2 and I2. So right hand side over left hand side, we have to write the Kc expression, that is concentration of the species on the right hand side. So H2 to the power 1, whatever the molar coefficient becomes the power of the bracket. And I2 to the power 1 divided by left hand side, that is Hi gas, the concentration to the power 2 because the molar coefficient is 2. Right? Now it says calculate the concentration of I2 present in the reaction mixture at equilibrium. Show your working. Now, how do we solve a Kc or Kp question? We write the equation, we make a table. All right? Always make a table so you can score the maximum marks. Do not miss out anything. So the reaction is that 2Hi gaseous goes into what? It goes into H2 gas, 1 mole of H2 gas, and 1 mole of I2 gas. Now I'll make a table. What are the headings that I need in the table? I need the initial moles of everything, whatever the initial moles were. So I need the initial moles, I need the used moles, and then I can find out the equilibrium moles, right? So what are the initial moles? Let's read out the question again and we'll know what initial moles were present over here. So it says that a sample of Hi gaseous is added to. So a sample, we do not know how much Hi gaseous is added. but we do know that it is added to a 2 dm cube sealed vessel. So what does that mean? What is the volume over here? Volume of container. That is 2 dm cube, right?
Yep.
So the volume is 2 dm cube. This is very important because whenever we try to insert any moles over here, those moles should be in what volume? They should be in 1 dm cube because the unit over here is mole per dm cube, right? So whatever the moles right now we have are in 2 dm cube. So we're going to have to convert at the end and find the moles that would be present in 1 dm cube. So that's why this volume is very important. So it says that at 764 kelvins, temperature is important because Kc is dependent on temperature. If the temperature changes, the Kc value changes. So we need to the question temperature to be constant, and at this temperature, the Kc value is this one. So we have the Kc value. So I do know the Kc value. I need to find the concentration of I2. How do I do that? Again, I'll fill the table. So at equilibrium, the mixture contains 1.70 mole of HI gaseous. All right. So if I have 1.70 moles of HI gaseous at equilibrium, are these the initial moles? No. Are these the used moles? No. It says that at equilibrium, you find these many moles. Right?
Yep.
So now I have to find how much equilibrium moles do these have, as does hydrogen have, and how many equilibrium moles does I2 have. So in order to do that, what do I have to do over here? I'm not given any initial moles from where I can subtract and find the used moles over here, and then I can find the formed moles over here. So I cannot do that. What do I do? So I do know that the initial moles of these two products would be 0, right? Because in the 2 dm cube container, you only put what? You only put HI gas, right? You do not put iodine or hydrogen gas. That means that the reaction starts and these were formed. So initially they were 0. I do not know how much I had initially over here. All right. But I do know that an amount was used over here, and then at equilibrium, I had 1.70 moles left of HI. Right?
Yep.
So now what I'm going to do is I'm going to forget about the initial moles of HI. Without that, I can do the question. How? I can assume that X moles were used from here. Or let's say, let's do it in the reverse order because the ratio would mess up if I start from HI. So if I start from H2 or I2, I need to find the concentration of I2 at equilibrium. Now, in order to find the equilibrium concentration, I'll assume that in this reaction, X moles of I2 were formed over here. Right?
Yep.
Now, forget about the initial moles of HI. We do not need those. So if X moles of I2 were formed over here, and there's 1:1 between both the products, how many moles of H2 should be formed over here? Also X moles, right? It's 1:1. Whatever the moles of I2 is formed, that's also the moles of H2 that is going to be formed over here. Is that correct?
Yep.
Because it's
Because it's 1 to
1:1
1.
between. But if X moles of I2 were formed over here, and it's 1:2 between I2 and HI, how many moles do you think should be used from the side of HI?
2x.
Yep, it should be twice the moles. So if X moles were formed, so if 1 mole was formed, 2 moles have to be used from here. So if X were formed, 2X moles were used from here. Right?
Yep.
So whatever the initial value over here, minus 2X, I do know the answer for that. I know that when I subtract these used moles, I get these equilibrium moles, and my only requirement was to find the equilibrium moles. So do I have the expression for the equilibrium moles of H2? If they were initially 0 and X were produced in this reaction, so at equilibrium, how many moles would I find? X moles, right? And if X moles of iodine were produced, initially they were 0. How many moles of iodine would I have at equilibrium? Also X moles, right?
Yep. Yep.
So now, do I have the equilibrium moles of all of the species?
Yep. We have
I
the
do
x.
have the equilibrium moles, right? So now what do? I can insert this. Since I have the Kc value, I can insert this in the Kc expression. Let's do that. So the Kc value was how much? It was 0.0217 So 0.0217 is equal to right hand side, I have X moles of H2 gas, I have X moles of I2 gas, and I have 1.70 moles of HI gases at equilibrium. So can I solve from here and find the value of X?
Yep. It would just be the half of 1.7, right?
It would be what?
Half of 1.7
No,
because it's
it will
X
never
and
be the
then
half of
2L.
1.7. Why? No.
Be
Listen, whatever the moles were here, right? So those
yep.
moles subtracted by the used moles, that's the moles that were left at what? Equilibrium,
Yep.
right? So now I have the equilibrium moles. Why am I making a ratio? This
Oh, okay.
ratio was only
Yeah.
formed because I needed to find an expression for the I2 moles and H2 moles,
Yep. Okay.
right? I needed the I2 moles. So I assume that if X were formed over here, same moles would be formed for hydrogen also, right? And 2X would be used from the other side. Whatever the initial moles, that I'm not concerned with. I'm only concerned with the equilibrium moles because in the Kc expression, it's an equilibrium expression. I need to put in equilibrium moles. But there's a problem over here. Did we consider that if these moles were in 1 dm cube or not? Did we consider that?
No,
We did
it's in
not.
2 dm cubed.
Yep. These are the moles that are present in 2 dm cube volume. What are the moles that I need to insert over here? Due to the square brackets, I need to insert the moles per dm cube. That means in 1 dm cube. Is that correct?
Yep.
Yeah. So if I have these moles in 2 dm cube, can I find out how many moles would I have in 1 dm cube? This is also in 2 dm cube.
Yep.
Can I find out how many moles would I have in 1 dm cube?
Yep.
Yep. So for HI, how many moles do I have in 1 dm cube?
0.85.
Yeah. So 0.85 moles in 1 dm cube, right? So per dm cube. And this would be,
That would just be 1/2 of X.
yeah. So X divided by 2. And this would also be X divided by 2,
Yep.
right? So that's the expression for 1 dm cube moles over here. Right? So now I can put those expressions in the equilibrium expression. So I have X by 2 moles of this, X by 2 moles of this, and I have half the moles of 1.70. That would be 0.85 moles. So now I need to solve this. So this becomes what? Let me add a paper over here. Let me add a page. So I have the expression as 0.0217. 0.0217 is equal to, I have X by 2 into X by 2 divided by 0.85. Right now I need to solve this. So I multiply 0.0217 multiplied by 0.85. And the other side becomes what? It's X by 2. So it becomes X square over 4. Right? So X square over 4. Now the 4 can multiply over here. So 0.0217 into 0.85 multiplied by 4. And the under root would be equal to X. Do you understand the math I did over here?
Yep.
Okay. So I moved the 4 over there and then I took an under root on both sides. So X is equal to what?
I'm getting 0.272.
So 272. And what is the value of X representing over here? Moles per dm cube. Right? Now I need to find out how many moles of I2 I have at equilibrium. Right? So I know the value of X now, but what were the moles per dm cube for iodine at equilibrium? They were X by 2, right? So I need to divide X values by 2 in order to find the moles of iodine that are asked in the question. So what's the value of iodine, that's 0.0272 divided by 2. 0.0272 divided by 2, how many moles?
0.135.
135
5.
moles per dm. So these are the moles of I2, 0.135. Are we clear with the question?
Yep.
All right. So the next question in this topical is from, let's do this question. And I hope it's not from the gaseous chapter. Let's do it. So the question says, methanol is made by reacting carbon monoxide with hydrogen. So we have the reversible reaction over here. It says that carbon monoxide and hydrogen react at a pressure of this much at 200 degrees Celsius. Eventually, the reaction mixture reaches dynamic equilibrium. Can you tell me what's the total pressure over here? Yep. It's this value.
The 1.
Yeah.
1 times
1
10 to
into
the
10
power
is
7.
power 7, because they're both reacting at this pressure, and then the reaction reaches equilibrium. So this is the total pressure. All right. So it says the table shows the amounts of species present in the mixture. And the first part is they've given you in the initial moles, and they've also given you the equilibrium amount in moles. So we have the equilibrium modes. So the question is going to be relatively very easy because we already have the equilibrium modes. We do not need to make any table or calculate the equilibrium modes, right? So what is meant by dynamic equilibrium? So what do we say? Yep.
It would be the same amount of reactants and products in the reversible reaction.
No.
The exact definition.
And wait, you have to remember the exact definitions.
Yep.
In definitions, there is no flexibility. All right. The examiner expects that all the definitions you know by heart. You have to memorize all these definitions. So when the rate of forward reaction is what is
Equal.
to the rate of backward reaction in a reversible reaction. And the concentrations of reactants and products, what do they do? Remain constant or same, right? They do not change.
Yep.
So that's the second part. That's the second mark in this definition. The first mark is that rate of forward and backward reaction is equal in dynamic equilibrium. And the second mark is for that the concentration of reactant and product remains the same after dynamic equilibrium, does not change anymore. So calculate the partial pressure of methanol at equilibrium under these conditions show working. So in order to calculate partial pressure of methanol, what do I need? I need to calculate the partial pressure of methanol. So I need to know the formula. So partial pressure of methanol would be equal to what? It will be equal to the mole fraction of methanol, right? Multiplied by the total pressure. That's the formula that we learned.
Yep.
Now I need to find the mole fraction of methanol. What's the mole fraction of methanol? The mole fraction of methanol would be the moles of methanol divided by the total moles at equilibrium, right? Of all the substances. So in order to find the mole fraction, I would do what? I'll take the moles of methanol at equilibrium. This is methanol. And I would divide them by the total moles at equilibrium. So let's first calculate the total moles at equilibrium. What are the total moles at equilibrium? What are the total moles? The sigma, the sum of all these.
I'm getting 1.06.
So 1.26 moles are the total
No,
moles.
1.06.
1.06 moles are the total moles, and the moles of methanol are 0.97. So I can find out 0.97 by 1.06 moles. I'll get the mole fraction, right? So I'll just write this fraction over here. 0.97 divided by 1.06. That's the mole fraction multiplied by what was the total pressure used? It was 1 into 10 to the power 7 pascals. So 1 into 10 to the power 7 pascals. Now I get my answer. What is my answer for partial pressure of methanol?
9.15 times 10 to the power 7.
7 Pascal, right? So 9.15 times 10 is power 7 Pascal. Is that clear?
Yep.
So I just needed to directly calculate the partial pressure. Now it says write an expression for the equilibrium constant Kp. So in Kp, do you mention square brackets or concentrations, or do you mention partial pressures of the reactants and the products? In Kp expression, Kp is only for gases. We only mention what? We only mention the partial pressure. So right hand side over left hand side, but the partial pressure of the species on the right hand side in the equation, that is methanol. So partial pressure of CH3, CH2OH to the power what? It's 1 mole over here, so to the power 1 divided by the partial pressure of H2 and carbon monoxide, but the partial pressure would have a square for H2. So partial pressure square for H2 and multiplied by the partial pressure of carbon monoxide gas. Very clear. This would be the expression. And in order to calculate the units, we can also calculate the units. So Kp, right now, what's the pressure unit that is being used in the questions? Yep. In our question, what was the pressure unit? PA, pascals. So what would be on the numerator? It would be Pascal times 1. And in the denominator, you have a Pascal square and you have 1 times Pascal again, right? So this Pascal cancels out with this Pascal, and the final Kp unit would be Pascal minus 2, right? So Pascal minus 2. Are we clear?
Yep.
All right. So question number 4 says 0.025 moles of HI is added to a closed vessel and left to reach dynamic equilibrium. The total pressure of the vessel is this. So we have the total pressure. All right, so equation 1 represents the reaction. Explain what is meant by the dynamic equilibrium. We've already done the definition. It is when in a reversible reaction, the rate of forward reaction and backward reaction becomes equal, and the concentration of reactants do not change anymore. And it says describe one initial difference in the appearance of the reaction mixture compared to the mixture at equilibrium. Yep. What would be the difference? That iodine purple vapors are being produced, all of the other gases were colorless. So a purplish mixture will be formed, all right? Or a darker mixture, darker colored mixture will be formed at equilibrium, all right?
Yep.
Write an expression for the reaction described in equation 1. So let's write the expression. For Kp, now you have to write the expression. So partial pressure of H2, that's on the right hand side, multiplied by partial pressure of I2, that's on the right hand side. And both will have a power 1 because both molar coefficient is 1 in the equation. And then on the left hand side, partial pressure of HI gas to the power 2. Why? Because it has a molar coefficient of 2. So this is the Kb expression. Now it says that at equilibrium, the partial pressure of HI is 86.4 kilopascals. Calculate the amount of HI present in the mixture at equilibrium. Show your working. So we know the partial pressure of HI. It's this much. We need to find the amount in moles present at equilibrium mixture, and we have to show your working. So we have the partial pressure, we need to calculate the amount in moles of HI. What should come to your mind if you see the value of partial pressure for HI? Should I apply the formula over here for partial pressure of HI?
Yep.
Yep.
So the final formula.
Formula over here, right? So partial pressure of HI would be equal to what? It would be equal to the mole fraction of HI into the total pressure. Right? I know the value of partial pressure, that is 86.4 kilopascals. That means into 10 raised to the power 3 pascals. I need to find the mole fraction. The total pressure, I know it's given in the question. It is 100,000 pascals. So it is 100 into 10 raised to the power 3 pascals. So now, in order to find the mole fraction of HI, I'll do what? I'll divide 86.4 into 10 is power 3 divided by 100 into 10 is power 3. So what do I get? Yep.
I'm getting 0.864.
0.864. But are these the moles of HI or is this the mole fraction of HI?
The mole fraction.
That's the mole fraction of HI. So what do I do now? Would I apply the mole fraction formula? The mole fraction would be the moles of HI divided by total moles at equilibrium, right? Of all the gases. That is equal to 0.864. What do I do now? Can I find out the moles from here?
Yep.
How do I find the moles from?
We need to know the total.
Do I know the total moles? Have you been given the total moles?
No, we haven't.
Yep. So what do I do now? I do have the initial moles of HI.
So then we
What
can
else do I
use the
have?
initial moles to get the total.
How do I use the initial moles to get the total? That's also a question. Because this partial pressure is due to the equilibrium moles, right? What do I do now? Can I somehow find the, let's make a table over here. So HI, 2HI, gaseous, goes into what? It goes into H2 plus I2. Let's make a table. So I have the initial moles of HI that are 0.025. These are the initial 0.025. I do not have any initial moles of this. I need to find the used equilibrium, then I'll go on to the mole fraction in the partial pressure. Right? For Kp, I need to find all these things. Let's talk about the used moles. So if X moles were used from here, how many moles of H2 and I2 will be formed on the other side?
X over 2.
Yep, half the moles, right? So X over 2 will be formed here. X over 2 will be formed here. So just to make my calculations easier, can I go in reverse? That if X were formed over here, how many were used for HI?
2x.
Yeah. So now it's easier for me, right? Do not have any fraction. So at equilibrium, how many moles will be left for HI? 0.025 minus 2x. And how many moles for H2? That would be X. How many moles for I2 at equilibrium? That would be X. So now I have the equilibrium moles. I need to ask myself, are these equilibrium moles in 1 dm cube of volume? Did they tell us the volume? No, they did not tell us the volume. So what do I do now? I assume that they're in 1 dm cube. All right. Now, in order to calculate the mole fraction for HI, what do I do?
You find x by substituting the equation that you created.
First, we need to find the total moles over here. Right? Total
Yep.
moles at equilibrium, and then I'll divide the moles of HI at equilibrium with the total moles at equilibrium to find the mole fraction for HI. So that would be how much? What are the total moles? That would be 0.25, 0.025. I'm still trying. Maybe we have to do this some other way. So 0.025 minus 2x, and then I have to add what in this? I have to add x, and then I have to add x. So this becomes 0.025 minus 2x plus 2x. What does this become? Becomes 0.025. Is that clear up till now?
Yep.
So the total moles at equilibrium are 0.025. What do I do next?
So you substitute it?
Yep. So let's substitute that. The moles of HI is 0.025 minus 2x, and the total moles at equilibrium were how much?
0.025?
Yep, it was 0.025. Now I cross multiply and I try to find x. Let's find x. So it's going to be 0.025 minus 2x is equal to 0.864 into 0.025. What does that become?
I'm getting 0.0216.
0.0216, right? And then 0.025 minus 0.0216 is equal to 2x. What is the answer on the left hand side?
0.0034.
And that divided by 2 would be equal to x.
Yep, which is 0.0017.
All right, so x is equal to 0.017,
017.
right? So now I have the value of x. Do I have the moles of HI right now, or I have the value of x?
We have the value of x.
Yeah, so in order to find HI moles, I'll go 0.025 minus 2 times 0.0017. How many moles have been left at equilibrium?
I'm getting 0.0216.
0.0216 moles. Zero point zero two one six moles. All right, let's do this question. So it says magnesium oxide reacts reversibly with chlorine according to the following equation. That's 2NgO solid plus 2Cl2 gas goes into 2NgCl2 plus O2. Under certain conditions, the dynamic equilibrium is established. State two features of a reaction that is in dynamic equilibrium. What are the two features?
The rate of forward and backwards is the same.
Forward reaction is equal to
Backwards
rate
reaction.
of backward reaction. And what is the second feature?
And the concentrations of the
Yeah.
reactants and products is the
Concentration
same.
of reactants and products remain what? Same. They do not change. Same does not mean that they have same concentrations. That means their concentrations remain constant. They do not change. All right.
Yep.
The equilibrium constant Kp is given by the following expression. All right, yeah. So I thought the question is going to be from the gas law, but it's not from there. So we can do this question now. So the next part says the equilibrium constant Kp is given by the following expression. So we've been given the expression. Let's read out the expression. So it's partial pressure of O2 from the right hand side divided by the partial pressure of Cl2 plus square, right? So why did we not mention MgO from the left hand side and MgCl2 from the right hand side in Kp?
Because they're solids.
Yep, because they're both solids, and in Kp only write gaseous phase, right? So that's why only these two were shown. It says that at this much pressure, which is what the total pressure, 500 kelvins is the temperature, 70% of the initial amount of Cl2 has reacted. Now it's very mathematical over here. If you had 100% initially and 70% has reacted, where did that 70% go first of all? Yep.
You had 100% and then 70% reacted.
Obviously,
So that would,
if we have the initial amount and we've been given that 70% of it has been converted, that means that the initial amount was 100%.
yep.
Right? It's very basic. So let's write the equation. It's 2Cl2 and O2 on the right hand side. I'm not going to write anything else, just 2Cl2 and O2 from the right hand side. All right, because others are gases, so I do not, sorry, others are solids, I do not want to mess with those. Just write the ratio, for the sake of ratio, write the equation. So I have this equation. Now I do know that initially, how much chlorine did I have? 100%.
Yep.
And if 70% of it has reacted, how much of it has reacted?
70%.
70%. So how much am I left with at equilibrium?
30%.
30%. But we do not use percentages, right?
Yep.
What we're going to do is we're going to use the
So we
let's
assume
say
it's
the
the
decimal number of
mass.
the percentage,
Oh, okay.
right? So 100% would be how much?
So,
One.
just one.
Yeah.
Yep.
70% divided by 100 would be how much?
0.7.
Yeah, 0.7. And then how much would be the remaining amount at equilibrium?
0.3.
Yeah, 0.3. So I just converted the percentages back into the decimal forms. Now think about it. If these many moles were used from here, how many moles of O2 should be formed on the right hand side? They were initially 0. So the equation says that if 2 moles are used from here, 1 mole of this is formed. So if 0.7 are used from here, how many moles are going to be formed for O2? Half of that,
Yep.
right? So 0.7 divided by 2 is going to be formed here. How much is that?
0.45.
0.45? Are you sure? Or 35?
Oh, sorry. Yes. 3.5.
0.35 moles were formed over here, right?
Yep.
Now what can I do? I can say that initially they were 0. 0.35 moles or 35% was formed over here. And the remaining at equilibrium would be how much? It would be 0 plus 0.35. So I have 0.35 moles of O2 on the right hand side. Right? So I
Yep.
have the equilibrium moles, both of them. Now I need to make sure that my container was of 1 dm cube. So it's not given over here. I'll assume that it's 1 dm cube. Now, what's the next thing? I need to calculate Kp, right? And state its units. So in order to calculate Kp, I need their partial pressures. In order to calculate partial pressures, I need their mole fraction. So mole fraction for Cl2 would be the moles of Cl2, that is 0.3, divided by the total moles. What are the total moles at equilibrium? 0.65 or 0.75? I think there's 0.65.
Yep.
Right? So 0.65 moles are present at totally at equilibrium, and out of that 0.3 is this. So mole fraction would be 0.3 over 0.65 and 0.35 over 0.65. That would give me mole fractions of both. So for Cl2, the mole fraction is
0.538.
0.538. And what is the mole fraction for the other one?
Oh, sorry. That one is 0.538. And then the first one is 0.3 divided by 0.65 is 0.461. So it's reversed.
Okay, so you have 0.538, and for the other one, 0.
461.
Now, in order to counter check, what do we do? The sum of mole fraction should be equal to what? Should be equal to
1.
1. Is it equal to 1 over here?
Yes, it's 0.999.
Yeah.
So
So that
yes.
is 1, right? So that means the mole fractions are correct. Now what do? I calculate partial pressure. In order to calculate partial pressure, I multiply the mole fraction of this gas with the total pressure. What's the total pressure? 1 into 10 to the power 5. So 1 into 10 to the power 5 pascals. And this would be 0.538 into 1 into 10 to the power 5 pascals. So what is the partial pressure of the first one, Cl2?
4.61 times 10 to the power.
4.61.
Yep. Times
Exact
10 to the power of.
4.61?
No. 4.61 times 10 to the power of 4.
10 to the power 4. And the unit
Yep.
would be pascals. And the other one?
That would be just 5.38 times 10 to the power of 4.
Pascals. Right? Now I have the partial pressures of both. Can I insert them in the Kp expression and find the Kp value?
Yep.
Yep. So Kp is equal to the partial pressure of O2 to the power what? On the right hand side, it's power 1, right? So I leave it like this to the power 1 divided by the partial pressure of Cl2 on the left hand side and square that. So 4.61 into 10 to the power 4 to the power 2. What is the value of Kp over here?
I'm getting 2.53 times 10 to the power of -5.
-5. And what would be the unit of Kp? So I have a Pascal on the top, I have 2 Pascals on the bottom, or a Pascal square on the bottom. So this cancels out with this. What's the final unit left? Pascal minus.
Kp by -1. Yep.
So this is our final answer. All right.
Yep.
All right, this is a very quick question. Let's do this and then we'll end class. HI can be formed by the reacting of H2 and I2. The reaction is reversible and in equilibrium forms at high temperatures. Construct an expression for the equilibrium constant Kp for the reaction of H2 and I2 to form HI gas. So how do I do that? Kp is equal to right hand side. On the right hand side, it's HI right now. So partial pressure of HI to the power 2 and partial pressure of H2 multiplied by partial pressure of I2 to the power 1 and power 1. Right? This is the expression for Kp. And for the next part, it says the equilibrium partial pressures of the gases are as follows. So I've already been given the partial pressures at equilibrium. Right? And if I want to calculate Kp, what did I have to insert over here for all the gases? Yep.
The partial?
Yep, the
Partial
partial
pressure?
pressures, and those are given in the question. So I just need to plug in the values. So Kp would be equal to the partial pressure of Hi. So Hi has 4,800 pascals, and I have to square that according to the expression divided by the partial pressure of H2, that is 895, and I2, that is also 895 to the power 1. So what is the answer? And remember, all these values are in pascals. So what's the answer?
28.8.
So that is 28.8. And what would be the unit? So I have a Pascal square on the top. So that means Pascal into Pascal. And I have a Pascal into Pascal on the bottom. So what would be the unit of Kp
No
over here?
units.
No unit. All right. So Kp is 28.8 and no unit.
Yep.
All right. So these are the type of questions that are going to be asked from you.